All right. Hey guys, hey Blue Group, this one's for you. All right, so I'm putting up a lesson today, and you guys do have a homework assignment based off of this lesson, okay? The due date for the lesson right now, we'll just say is by Sunday night. We're trying to be convenient and lenient with times. I will also add that if that we are going to be doing Google Meets as a class online. The Google Meets are not mandatory, but I definitely know that there are some of you who would appreciate being able to meet face to face with me to answer any questions that you might have. So the Google Meet that I'm planning is for tomorrow. The date and time will be posted in the Google Classroom. This is my first ever video, like teaching a lesson, so it is a learning curve. I have to be patient with you guys, hence your assignment's not due till Sunday night. And I need you to be patient with me as well while we figure out what we're doing. All right. So you guys are currently on chapter or goal 3. Okay. That's where we're at right now. So our lesson today is going to be on converting percents to decimals and decimals to percents. You have a lesson or a homework assignment in the Google Classroom, and then you have kind of another activity that I'm going to require of you afterwards. I'll explain that when we get to the end. So I just wanted to model and go through any misconceptions that you guys may have, and just show you how it's done. All right, so again, what we're doing today is we're converting decimals to percents, and we're actually also going to go backwards and convert percents to decimals as well. So some things that you need to know. Percents, the word percent means per 100, okay? So it means basically out of 100. So if you're looking to convert a decimal or any number to a percent, you take it, and basically what you're doing is you're multiplying by 100, all right? Now, that does not mean add 2 zeros to the end. That's one of the biggest misconceptions. It's usually derived somewhere in like elementary school. They're like, oh, 3 times 100, 300, just add 2 zeros. And I don't know, 10 times 100, 1,000, right? Just add 2 more zeros. And it works in elementary school, and therefore it reaffirms it, and then everyone thinks that it's okay, when in fact it's not okay, all right? It's a really sneaky trick because it only works sometimes. And what I mean by that is what's actually happening when you multiply by 100 is our number system is a base 10 number system. What you're actually doing is moving to place values, okay? So in elementary school, when you're only working with whole numbers and you multiply by 100, it looks like you can just add 2 zeros onto the end and call it a day. However, as you get older, you find that that does not always work. And I'm going to give you some examples of when that does not always work, all right? So specifically when you're dealing with decimals, you'll see it a lot. So we're going to run through these 5 examples here, converting these from decimals to percents. Now, if we were in the classroom, ordinarily, we would actually take 0 and 53 hundredths right here, and we would multiply this by 100, and we'd recognize a pattern. All right, so if you have a calculator right now, go ahead, pull it out, 0.53 times 100, all right? You can get your 0 and 48 thousandths. Multiply that times 100. 4.67 times 100, 0.9 times 100, and 7 times 100. Now you're going to find that the only number that you can add 2 zeros onto and get the accurate answer is the 5th example down here with 7. All right? For these other decimals, it's not going to work if you just add 100 on. What you are going to recognize as a pattern, though, is that every time you multiply by 100, what's actually happening, as I just mentioned before, is your decimal point is moving to place values because we have a base 10 number system, all right? And 100 is 10 to the 2nd power, so you're actually moving to place values. All right, so let me show you what it looks like. What color do I want? Let's use red. All right, so one of the first things you need to do is identify where your decimal point is, okay? In this case, the number that we're working with is 0 and 53 hundredths. That's the formal name for it, all right? Here's my decimal point right here. and you move your decimal point 2 places, 1, 2, and then it becomes a percent. And that's it. That's how you change a decimal to a percent. Our answer is 53%. So you should always be asking yourself, does my answer make sense? Okay. Percents sometimes can be greater than 100% if your number is greater than 1. 0 and 53 hundredths is certainly not greater than 1, so therefore my answer is not greater than 100%. All right? It makes sense. All right, 0 and 48 thousandths. All right, I move my decimal point. It's right there. I gotta identify where it is. So there's my decimal point, and I need to move it 2 places to the right to demonstrate multiplying by 100. And that is where it becomes, and I add a percent to show that I'm done, and it is now a percent. So my answer here, notice this is where my new decimal point is 4.8%. Okay? So yes, sometimes you will still have a decimal in your final answer, and that's okay. But here I moved it 2 place values to the right. It is 100 times greater. All right, it's out of 100 now. So 4.8%. All right, 4.67. All right, so this time I have a number that's greater than 1. I'm going to get a percent that's greater than 100. Okay, because I have a number that's greater than 1. So when I go to move my when I go to move my decimal, 1, 2. Add my percent onto the end. So in this case, my decimal is all the way at the end. So is 467. And I don't need to do point percent. That's not necessary. If it's just a 0 at the end, you don't need that. So that is 467%. And I'm not surprised that it's greater than 100 because my number was greater than 1. All right? So when you have a number that's less than 1, your percent is going to be less than 100. Okay? As we saw in examples 1 and 2. Both of those as decimals, 0.53 is less than 1. My percent, therefore, is less than 100%. 0.048 is less than 1. My percent is therefore less than 100. But 4.67 is greater than 1. And therefore, my percent is greater than 100. Okay? All right. For the next one, number 4, 0.9. I purposely chose this number because it has nothing right there. All right? So what happens? When I do this, when I go to move my 2 place values, going to have to remember that even though there's nothing there, we have a number to represent nothing, right? We call that number 0. So I move 2 place values, add my percent, and my number is 90% as a decimal. Okay? Again, if my decimal point lands at the end and there's nothing after it, just the percent sign, you don't need it. Okay? You only keep the decimal point if there's actually a number after that value. Okay? And 7, all right, we're going to write 7 as a percent. Now, when I go to do this, let's think about this. 7 is 7 wholes. It's greater than 1. Therefore, my percent is going to be greater than 100. I also need to recognize that I don't see a decimal point right here. So we have to know where the decimal point goes on whole numbers, right? So the decimal point is understood to be right here, right? Just like if it was $7, it's understood to be there. You need to know that and recognize it. Every whole number has a decimal point at the end of it. It's not good math grammar to write it, so we don't always do it, but understand that it's there. Now when I go to move 2 place values, move 2 spaces, add my percent sign. There's no number after the decimal point, so I don't need it. And this becomes 700%. And that is how we go from a decimal to a percent. I'm going to try and switch sides here so that you can see what's behind me. We're going to go now from a percent to a decimal, okay? So when you go from a percent to a decimal, you're going in the opposite direction, all right? So let's think about this. Before we multiplied by 100, what's the opposite of multiplication here, or what's the operation that we consider to be opposite of multiplication? Division. I'm not going to door explore you guys and be like, do I hear you? Not yet, at least. Okay, so we're going to divide by 100, all right? We're going to go backwards now. And you can use this method to check your work as well for the other side. If you wanted to check your work for any of these, take your percent, divide it by 100, all right? So over here, let's try to stay focused a little bit, sorry. Over here, we're gonna go from our percent to a decimal, all right? So we're going in the opposite direction. We're going to be dividing by 100. Last time we move our decimals, our decimal places 2 places to the right. If you're thinking the opposite of 2 places to the right is 2 places to the left, you're on the right track. So let's do exactly that. I'm going to move some of these letters because I'm definitely going to need space for them. All right. So let's start off with letter A, example A. So here's my number as a percent. It is 5.63%, and I want to move that to my decimal point to the left 2 spaces. So here is, let me emphasize where my decimal point is right there. And now going to a percent, I'm going to go 1, 2, and that's where my decimal point goes. Now, since we're going from a percent to a decimal here, we don't need a percent sign in our final answer. We're not converting it to a percent. We're converting it to a decimal. So we need a decimal point in our final answer here. So I have a 0 placeholder, and my new value is going to be represented as 0.0563. Okay? I'm going to shift the camera a little bit. Okay. All right. And that's it. And if I wanted to check my work, I could just take my decimal point, move it back 2 places. Oh, there it is as a percent. There it is again as a decimal. All right, so 18.7% as a decimal. So again, I need to move back 2 place values. So I go back 1, 2, and that is where my decimal point goes. Now I always, it's a good rule of thumb to put a 0 before your decimal point if there's no whole number, okay? That's to make sure you don't make a careless mistake and other people recognize your number. So it's not always just about you. If you're doing math for a business or whatever have you, other people need to be able to read your numbers and understand them. And it is good math grammar to put that 0 right there so that they understand that it is 0 values, 0 whole numbers there. So it's 0.187 or 0 and 187 thousandths is the proper name of that decimal. All right, we've got 3% here. So again, this time I don't have a decimal point in my number already. Okay, that means we start from where the percent sign is. All right, so in example A and B, there was a decimal in the original value. This is not the case for example C. There is no decimal point. So we need to recognize that the decimal point is actually where the percent sign is, right? There's just no number after it, so there is no need to write it. So now when I do this, I'm going to start from here. I go back 2 spaces, and I remember I have to use my 0 placeholder. This is where my decimal point goes. So 3% as a decimal is 0.03 or 0 3/100ths. Okay? So again, if there is no decimal point, you're starting from where the percent sign is. All right, for 6.35%, I think we get the hang of it now. We have to go back. All right, 0 placeholder and the decimal. Our new value is 0.0635. Okay. And 1.9%, I go back to place values, 1, 2, I need a 0 placeholder, and that becomes 0.019 as a decimal. And because we're thorough and we don't want to make careless mistakes, we check our work when we're done. All right? Time me. Let's see how long this takes. All right, so if I move back to 1, 2, 1.9%, 1, 2, 6.35%, 1, 2, 3%, 1, 2, 18.7%, 1, 2, 5.63%. It doesn't take much time, guys. Put in the effort. It's worth it, all right? Especially when you're dealing with numbers, real numbers that mean cash values in the future, okay? You don't want to learn the mistake, to correct your mistakes the hard way, and it costs you. All right, so I mentioned before that you guys have an assignment on ALEKS based off of this assignment, based off of this lesson right here. All right, so if you're done watching this video, you can go over and complete that assignment right now. I'm just going to label it with today's date. It'll be assignment 3/25/2020 because that's today's date. Okay? And I also mentioned there's one other activity. All right? Everyone's home, I believe, at least. So, it's a box of mac and cheese. Mac and cheese is not really the important part here. The percents on the box are. So this box actually happens to have 2% listed on it, all right? One side, I believe, says like as packaged. If I focus, it's not focusing. Come on. Okay. Well, one side is as packaged and the other side is just prepared. Well, because I don't eat mac and cheese raw, I'm going to focus on the percentages that are as prepared because I cook my food before I eat it. All right. So, and season. All right. So, on this side, you're going to notice that there's a bunch of percents that correlate to the percent of the daily value that's recommended by like the FDA, I believe. So it says, for example, total fat in this is 13% prepared. I want you to find your own food item, okay? You're going to take a picture of your food item, okay? And to show me that you watched this video, you're going to take a picture of whatever item of food you have, and you're going to write down at least, okay? At least 5 of the percentages of the ingredients and convert them to a decimal, okay? It's already given to you as a percent. So for this one, you're going from percent to decimal. So for 13% of the daily value of the total fat right there, I know it's a little blurry for you guys, but that's what it says. I'm going to convert that and say total fat, 13% is equal to 0.13, all right? I'm just going to jump down and do the bolded ones. Next one is the cholesterol. There's 3% cholesterol in this box as prepared, or 3% of the daily value, I should say. So I'm going to say cholesterol, 3%, 0.03 as a decimal, okay? So find an item in your house, and we'll probably do more with these and figure out what those daily values actually mean, but first we need to know how to go from decimals to percents. So, It was fun, sort of, not being interrupted. Have a ask any questions that you have below, and hopefully I can get to them when we do our Google Meet tomorrow. Okay?